So example 2 has a double root, which means that it has a repeat answer. So it might be like 5 and 5, 2 and 2, so on and so forth. So you only list one, so technically it only has one solution. So in example 2, they tell you that it's a double root. What's happening here is that your vertex is either hitting going up in one spot or it's hitting and going down in one spot. So as long as we can find where the vertex is, you'll get that double root. Now, if they don't tell you that it's a double root, then you'll have to go ahead and graph everything. But because this is telling me that it's a double root, I don't have to solve too much. Okay. First, looking at this equation here, it needs to be equal to 0. Needs to equal 0 before you start. So the 16 needs to get added to the other side to be all in one line. The reason why that is because you're going to end up messing up your signs and stuff. It has to be all on one side. Okay? So let's go ahead and take a look at this. So we have 16 for a y-intercept, and that is nowhere on the graph that they gave us. So I'll put it on there. It's right there, but I don't know if it's going to help us. We also have to find the vertex. Okay, so starting off with the axis of symmetry. So let's see, negative b over 2a is negative 8 divided by 2 times 1. So that's 4. 4. So I can tell you right now, let's put this other 16 up there. I can tell you right now that we don't really need to go much further. I know that if it has one root, it's going to hit on the x-axis, right? That's where you find your zeros. But let's go ahead and plug it back in just to be sure that we got everything right. So I'm going to type in 4 squared minus 8 times 4 plus 16. So let's see. Yep, that equals 0. So we have there. Whoop. Whoop. Okay. So my solution is 4. Yep, that's what happens with you when you have a one root. So this one actually has 4 and another 4, but we don't list the other 4. We just list 1.